So here's another problem. It looks almost like anything else you've done. I will say this one is 5th degree. That means we're going to have to do synthetic division 3 different times to get this thing to work out. Once you get down to x fourth, once you get down to x cubed, and then once more to get down to x squared. I'm going to go ahead and put it in decimals like I always do. I did that earlier. And the graph, I just took a screenshot of the graph. This is me putting it in decimals. That's what it looked like. And the graph itself ended up looking something like this. And I'll just notice again that like here, when x is presumably like -1, the graph touches the x-axis and bounces off. So I know this -1 will work more than one time. At least once on my synthetic division. And I also notice there's a 4 over here that's working. And then it looks like the graph doesn't cross any other x-axis anywhere else. So that's kind of weird considering it's 5th degree and we'll have to do this 5 times. So let's see what happens. I just know in my head I'm using -1. I'm going to use -1 a second time. And then I'm also going to use the 4 to get this thing all the way down to 3rd degree. So as I set up my synthetic division, that's for the x to the 5th, x to the 4th, x cubed. I'm going to pause this and let you guys do the work yourself. But based off the graph, I want to say, I know -1 will work on the outside at least once, so I'll use it twice. And based off the graph, I know 4 is going to work. So you're going to see me do a -1 with a synthetic division, another -1 with a synthetic division, and then one more synthetic division with a 4. When you unpause the screen, that's what you'll see. So since this is a homework problem that you have to do anyways, you might as well just do this in your notebook as well and see, you know, where my work and your work match or don't match. I'm going to pause my screen now. Maybe just pause the screen at this point and look at my work and look at your work. You know, anytime 0 shows up in the work itself, it gets confusing. So, you know, if your work does not look like mine, chances are it happened around where we started to have to work with 0. You see kids make all kinds of weird mistakes when 0 pops up. But ultimately, this is what you should end up with. And I just want to reiterate, the idea was that this one initially represented an x to the 5th. And so this, if this represented x to the 5th, that was x to the 4th. And if that's x to the 4th, that's x cubed. And if that's x cubed, that's x squared. So I had to do that synthetic division 3 times, as promised. -1 worked more than once because of that bounce off the x-axis, and then we saw the 4 working as well. Now the quadratic we're left with, if this is x squared, there's no x's at all, plus 4. We're supposed to find the zeros of this quadratic as well. And what you'll notice about this one is since that middle term was 0, I don't actually have to use the quadratic formula here. We can with a b value of 0, but we can also use reverse PEMDAS because there's only the one kind of x. So I'm going to go ahead and do that. I'm going to actually use reverse PEMDAS at this point. That's a perfectly valid way to solve a quadratic if you have just the one kind of x. I'm going to say, what happens when x squared plus 4 equals 0? Because that's what we're trying to do, right? The quadratic formula is one way to find the x values that make the quadratic 0. Another way to find them is to set the equation equal to 0 and just solve it. Either way, we're finding the zeros, whether we're using quadratic formula or physically setting the equation equal to 0 and solving it, we're finding zeros. Now, I'm going to use reverse PEMDAS here. So this is what I'm trying to isolate. I start at the bottom. Here's my equation. Is there anything that needs to be added or subtracted? Yes, there is. This negative, this 4 has to go. I'll subtract 4, I'll subtract 4. Check. That gives me x squared equals -4. I move up that ladder. Hopefully this feels familiar to you guys. Is there anything on this side of the equation that should be multiplied or divided? There's not. I'm not going to do anything with that step. Move up the ladder. There is an exponent that's got to go. So I'll square root and I'll square root, and then that's where the trouble comes in. Because really we're not supposed to square root negative numbers. You might remember earlier this year we talked about that real number line, that thing you learned about back in kindergarten. And nowhere on this number line is there a number that I can multiply by itself and get -4. But we can use complex numbers. We can use imaginary numbers. We had the idea that there's this imaginary unit that when squared equals -1. And if you square root a negative number, you pretty much just pretend like it's not a negative number. So in my head, I'm going to pretend the negative's not there. The square root of 4 I know is 2. I put the square root in there, so it's plus or minus. And then it was negative, so I'm just kind of imagining that it's possible that I do this, so I put an I on there. This is none of these numbers. It's a different number that's actually on a different line that goes this way, but that's for a different class. I'm just throwing that out there for your edification. But that's it. There's 2 imaginary zeros. That's why we didn't see the graph cross in any other place. We saw this graph cross at -1 and at 4. It didn't cross anywhere else. There were no strange decimals because the other 2 zeros were imaginary. They were not on that number line. They're not on that x-axis. So as a final answer, the zeros of this polynomial are anything that works in the synthetic division. So -1 is one of them. 4 is one of them. I don't need to write the -1 down 2 times. If you do, I won't be upset with you. And then the other 2 zeros are imaginary. It's plus or minus 2i. And I'm done. Whoa! That's the end of that problem. That's what's going to happen in the homework. Just hopefully you guys are getting more familiar with quadratic formula, synthetic division, and how to use the graph to help you. That is the goal. Good luck, my friends.